Dear students, this video will take you through questions 1 to 10 of section A. Let's take a look at section A, question 1. Now, this is a very typical question on the scientific inquiry, asking you about attitudes of good scientists. John wanted to find out how much weight two toy cars, toy car A and toy car B, could carry before braking. He predicted that toy car A would carry more weight. However, the experiment results did not match his prediction. John was disappointed but did not change his data to fit his prediction. Question here is, which attitude of a good scientist did he display? Let's highlight together this last part. Did not change his data to fit his prediction. Now, this is the key phrase in the question. And if someone stays true to the data, right, one way of describing this person could be honest, okay, or showing honesty. And we know that another word for honesty is integrity. Thus, the answer for question 1 is B, integrity. Let's move on to the second question. The second question is on the drawing of apparatus. Which is the correct 2D drawing of the apparatus used to hold the filter funnel during filtration? Why don't we label what these four apparatus are? Okay, the first one, tripod stand. Let's write it down. B, this is a retort stand. C, this is a filter funnel. And D, this is a bell jar. Now this would be the more uncommon one, okay, because we have not really used it in any experiment, but every one of you should be familiar with A, B, and C, the tripod stand, retort stand, and filter funnel, because we have actually handled these in the lab this year. Okay, now let's visualize the filtration setup. Okay, and I'll do so by drawing how a filtration setup usually looks like. Okay, I'll use the space on the left hand side. Now we know that in a filtration setup, there is a filter funnel. On the filter funnel, we have a piece of filter paper. And below, to collect the filtrate, we have usually a beaker. Okay, now I'm using freehand to draw this, but remember that for all apparatus drawings, you should be using a ruler to help you draw straight lines, okay? Now, this is how it would look like, but usually, of course, we will pour what we want to filter through. So, it will probably look something like this with a beaker over here. And what is happening here is that, right, you are pouring the liquid, the suspension that you are trying to filter, and what happens is that the residue will be left on top of the filter funnel and the filtrate will pass through. Now, what is used to hold this filter funnel over here? Straight away, we can eliminate a few of the options. Okay, C, you can't use a filter funnel to hold the filter funnel, so I can already eliminate C. And D, the bell jar, is not used to hold any apparatus, so I can also eliminate that. Tripod stand or retort stand. You will recall that usually there is a certain apparatus that is found underneath the tripod stand. Okay, now I'll draw it for you. This would be the Bunsen burner. Why? Because the tripod stand holds, for example, a beaker, all right, on top of the flame, so that whatever is in the beaker can be boiled. Thus, the tripod stand is used mainly in heating. When you're using a Bunsen burner, to get up a Bunsen burner, right, you use a tripod stand and you put a mesh on top, and you can put your beaker or whatever you want to heat up on top of it. Thus, the correct answer in this case would be the retort stand. Okay, you look at this clamp over here. Okay, I'm going to circle it. This clamp over here would be used to clamp onto the filter funnel so that it can be suspended on top of the beaker that is being used to hold the filtrate below over here. Thus, the answer for question 2 is B. We'll move down to question 3. Question 3, the diagram below shows a Bunsen burner. What is the part labeled X? Now, this should have been committed to memory. Okay, so the correct answer here is B, barrel. Question 4. Now this is asking you on your knowledge of hazard symbols. So let's read the question together. A laboratory assistant working at the Center of Infectious Diseases wants to discard used COVID-19 swab tests. She puts them into a waste container and seals it up. Which hazard symbol sticker should she paste on the waste container? Let's highlight some of the key phrases and keywords in the question itself. Okay, so Center of Infectious Diseases, and we know that COVID-19, right, has to do with biological substances. Okay, we all know that the swab test, or even if you are not very familiar with it, we all know that the swab test, right, is used to take a sample of mucus from the human's respiratory tracts. Okay, so what they do is they actually take this very long cotton bud looking thing. So what they do is they take this long cotton bud like object and they stick it into the nostril of the patient. So we know that over here there is some biological substance, biological waste matter being handled. Let's identify what these hazard symbols are. Okay, this will help us later when we are trying to find out the correct answer. Okay, first one, biohazardous, usually in terms of bacteria, viruses, and other biological matter. B, this cross stands for irritant. The skull C stands for toxic. And finally, D is corrosive. So since we are handling the viruses over here, we can safely say that the correct answer is A, biohazardous. We'll move down to question 5. A student conducts an experiment to investigate whether balloon A or balloon B, made of different materials, can contain more air without popping. Which correctly identifies the independent variable? Independent variable, you should have remembered it as the variable that we change. Okay, it is the changed variable. So if I'm trying to investigate two balloons made of different materials, what am I changing here? The material of the balloons. Okay, thus the correct answer should be B, material of the balloons. Let's now move on to question 6. Now, question 6, you are given a table, and this is the scale of hardness. Okay, you are told that the harder the object, the higher the scale number. We see 4 different materials over here. We have fingernail, steel, topaz, and diamond. Now, even if you've not heard of these materials before, it's okay. Don't panic. You are given enough information in the table for you to answer the question correctly. Okay, so let's look at the scale hardness scale number. Fingernail has a hardness scale number of 2.5, is the lowest. Followed by steel, 6.5, followed by topaz, 8.0, and diamond, 10.0. To help myself, what I like to do is to annotate on the diagram or on the table itself. Okay, so we know that the harder the object, the higher the scale number. So let's figure out, or let's write down which is the hardest and which is the softest, okay, or is the least hard. Okay, so diamond with 10.0 is the hardest. And fingernail, we could just write the softest. So which is correct? Hardness, right, has to do with whether a material can scratch the other material or not. Okay, so a harder material will be able to scratch a softer material. And right, the converse would be that the softer material will not be able to scratch the harder material. So based on what we have in the table, we know that fingernail cannot scratch diamond, but diamond can scratch the fingernail. Okay, so now let's take a look at each of these statements and let's see which is correct. Fingernail is able to scratch topaz. Now fingernail 2.5, topaz 8.0, incorrect. Option B, steel is able to scratch only two materials. Let's see. Steel, in this case, we see it can only scratch fingernail because topaz and diamond have a higher hardness scale number, which means it's harder. So also incorrect. C, topaz is able to scratch steel but not diamond. Let's annotate topaz 8.0, steel 6.5, diamond 10.0. And yes, it's correct. Okay, topaz is indeed able to scratch steel, 8.0 is more than 6.5, but not diamond with 10.0. So the correct answer for question C is, for question 6 is C. Let's now move along to question 7. Question 7 requires you to recall how to use the grid method to find out the approximate area or the estimated area. Okay, some important things to note would be that the length of each grid square is not 1 cm, it's 2 cm. So this means that the area of each grid equals to 2 times 2 equals to 4 cm squared. So we have to bear this in mind later when we are calculating the area. Okay, so right now we are going to use ticks to count the number of grid squares that are at least half covered. Okay, so you should definitely use a pencil, okay, to tick this. In case you change your mind, you are able to erase it without any trouble. Okay, let's count the number of ticks that we have written down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So the approximate area, 23 times 4, okay, you should get 92 cm squared. So the correct answer here is option D, 92 cm squared. Question 8. The diagram below shows the reading on a Vernier Caliper. What is the reading on a Vernier Caliper? Now this is a classic Vernier Caliper reading question. So what I like to do is that because I know that the Vernier Caliper has an accuracy of 2 decimal places, what I will write for myself is blank, decimal point, blank, blank. Okay, and I'll fill in these blanks in a systematic way. Okay, so let's look at the 0 line on the Vernier scale, which is the bottom scale. And then for the first digit, okay, we will look at these large numbers on the main scale of the Vernier Caliper. Now we see that the 0 line lies between 2 and 3 on the main scale. Okay, so this means that the measurement is a 2 point something, okay, because it's over here, you see? So it's a 2 point something. Let's figure out what is in the next blank. Alright, so 2 point, this is 2.1, this is 2.2, 3, 4, 5, 6, 7, 8, 9. Now we see it's between 2.8 and 2.9. Okay, so 2.8 blank. Now for the last blank, we have to look for the matching line. Okay, so if you take a look, 0, 1, 2, 3, 4, only 4 on the Vernier scale is a matching line. Okay, it matches perfectly with the line on the mean scale. Thus, our reading is 2.84 cm. Okay, so option A is the correct answer for question 8. 2.84 centimeters. Let's now move on to question 9. Question 9 asks you about the parts of the Vernier Caliper. Okay, so let's take a look. We've got P, Q, R, and S. So, P. Now, these jaws over here are used to measure the inside diameter. Okay, so for example, if I have a cup, okay, or if a glass, if we imagine this to be the outer diameter, okay, imagine I'm looking at the cup from the top, okay, from the top view. So this will be the outer diameter, and there will be a layer of, let's say this cup is made of plastic, okay, so there will be, of course, the plastic rim of the cup, okay, that makes up the body of the cup. Okay, so P actually allows us to measure this inside diameter of the cup. Okay, I know my drawing is not the best, okay, but this is the inside diameter because these, okay, these two lines over here will be positioned over here and over here of the cup. So, P are my inner jaws. Okay, I'll just write it here, inner jaw. Q will allow me to measure the outer diameter. Okay, so I'll be able to clamp here and here. Okay, so that I can measure, what I measure is actually this outer diameter of the cup. Okay, so these are my outer jaws. S and R, okay, R is the tail, measuring the depth of a cup. Okay, I can put it in to the cup and I can measure how deep is it. And finally, we've got S, which is the vernier scale. So, the only option that matches all of these would be option C. Thus, this is your answer. Let's now look at the last question for this video, question 10. A cube has a mass of 270 grams and a volume of 30 cm cube. What is the density of the cube? Let's write down our density triangle, shall we? Okay, so we know that density equals to mass over volume. So my density triangle will look something like this. D equals to m over v, like that. Okay, so I want to find density. I've got mass, 270. I've got volume, 30. I should be able to find my density. 270 divided by 30, you get 9.0 grams per cm cube. Thus, the answer for question 10 is A.